Hi, myself Paras Kailas Davne, and I am here going to give a presentation on a topic of a decision models, that is the assignment problems. Assignment problems is a fundamental concept in decision making and operations research. It involves finding the most efficient way to assign a set of tasks to a set of agents, example workers, machines or locations, such that each task is assigned to one of agent and total cost or time or distance is minimized or the total profit is maximized. The profit agenda is to maximizing the product organization profit and minimizing the cost and time required for performing the tasks. An assignment problem typically deals with a set of agents, example workers, a set of tasks like jobs, a cost or benefit matrix where each element represents the cost of assigning a particular agent to a particular task. Mathematical formulation: let there be n agents and n tasks. The cost assigning agents triple I to the cost assigning to the j. It's a binary variable as here is shown in the example. Solution method: the most common method used to solve the assignment problem is to the Hungarian algorithm, which solves it in a polynomial time. Types of assignment problems: balance, unbalanced, maximization, variations. The balance number in the balance assigned problem means the number of agents is equal to number of tasks. Unbalanced assigned problem means extra dummies rows columns are added to make it balance. Maximization version means convert to the maximization by subtracting from the highest value. The applications of these methods are workforce assignment, task scheduling, machine loading, vehicle routing, college course allocation. Now here on the screen, four workers, that is A, B, C, D is given, and four jobs, that is job 1, job 2 and job 3 and job 4 are given. So here we will go discuss how to solve the solution. Step by step solution of Hungarian method is: step 1, row reduction. In here we have to reduce the rows, as we have to select the minimum lowest number in from the each row. Then second step is column reduction. Then we have to subtract the minimum value of each column from every element in that column. Now the third step is cover all zeros with minimum number of lines. Cover the all zeros using the minimum number of horizontal vertical lines, means we have to total the zeros which have we have cut, that is in a horizontal and vertical lines both. Then we have to plus the all the related data which has come after the subtracting. Then we will get the total cost required for the work done. Now we will go with the second problem, that is a transportation problem. The transportation problem is a type of linear programming problem that deals with the finding the most efficient way to distribute a product from multiple suppliers to multiple consumers while minimizing the total transportation cost. Means here that which cost will which method will be efficient for the low transportation cost. Components of transportation problem: sources, where goods are supplied from, each sources has a certain supply. Destinations, where goods are demanded, each destination has a certain demand. Cost matrix, a tablet that shows the cost of transporting one unit from each sources to each destination. Supply constraints, each source can only seed a limited quality. Demand constraints, each destination requires a specific quantity. Objective, to minimize the total transportation cost while satisfying all supply and demand constraints. Balance versus unbalanced transportation cost. Balanced transportation cost means total supply is equal to total demand, means it is a balanced cost, and unbalanced cost means total supply is not equal to the total demand, in that a dummy row is added for the balancing purpose. Here on a screen is an example of our transportation problem is given, in which data from S1, S2, S3 and demand D1, D2 and D3 is given. Here D1, D2 and D3 and S1, S2 and S3 are equal, that it's a demand supply. So this sum is a balanced type of sum. Now we will go through the decision theory. Decision theory is a framework for making logical choices in a phase of uncertainty. It provides tools and methods to help individuals and organizations make better decisions by evaluating possible outcomes and choosing the best alternative based on the preference or goals. Key elements of decision theory are: decision maker, the person or group making the decision; alternatives, different actions or strategies available; state of nature, future events that are not under the control of the decision maker, example market conditions, weather conditions, etc. Payoff table, a matrix showing the outcomes, profit, cost, etc. for each combination of decisions and state of nature. Probabilities, in probabilistic decision, livelihoods assigned to the each state of nature. There are three types of decision. The three types of decision are decision making under certainty, decision making under risk, and decision making under uncertainty. So we will go first through the decision making under certainty. The outcome of each decision alternative is known with certainty. Choose the alternative with the best outcome. Decision making under risk, states of nature are uncertain but probabilities are known. Use accepted monetary value EMV or accepted opportunity loss EOL. Decision making under uncertainty, probabilities of states of nature are not known. Several criteria are used like maximum, minimum, minimax, regret, lapse space. I here end with my presentation. Thank you.